Hello students, today we are doing motion problems, and these are word problems that we're going to solve by using systems. But the first thing we need to do is figure out how to write out the systems from the word problem. So we're going to start this one, and I'm going to write out the whole word problem, and I want y'all to write it out also. So it says two cars start toward each other at the same time from towns 612 miles apart. And they're going to pass in 6 hours. Okay, I have a few more to write down here, but I want to make sure that you're writing this down because we're going to be drawing some things in here, circling things, and I want you to be able to have it written down in your notes. So write down two cars start toward each other at the same time from towns 612 miles apart and pass in 6 hours. One travels 2 miles per hour faster than the other. How fast is each car traveling? Okay, so we're going to do a couple of things here. Make sure that you get that all written down. If you need to, pause the video and write it down. Okay, we're going to draw some pictures. We're going to make some tables. We're going to do a lot of different things here, okay? But the main thing that you need to know with your motion problems, and I probably should have written this up sooner, was your motion formula, okay? And that is, let's see, where can I write that? I'll write it down here. It's not really called a motion formula, but we're going to call it that for this section. And that is RT equals D. And that means the rate times the time equals distance. So in other words, if I'm going 25 miles per hour and I go for 2 hours, then I'm going to have gone 50 miles. Okay, so that's what that means. Okay, so we're going to use this to solve our problems today. Okay, so let's go back up to the car problem. I should have written this up at the top before I wrote all that. Okay, so I'm going to draw a picture of these cars. Okay, I'm going to have a car here, and I'm going to have a car here. Okay, those are my nice pretty cars. And remember, in the problem it says that they're 612 miles apart. So I'm going to put that in my picture. I'm going to put that they are 612 miles apart. And then I'm going to show that they are, one's traveling this way and one's traveling this way. Now, why did I make one of the arrows longer than the other one? Maybe I should have done it even more long. Oops. So why is this car's arrow longer than the other car's arrow? That's because it says up here that one's going faster than the other. Okay, so this car's going to get there before the other car because he's going faster, right? So now I'm going to look at what I need to know up here. It says, I want to know how fast is each car traveling. So I actually have two answers here, and that's why this is a system. Okay, so I'm going to make X is going to equal the rate of the faster car and Y is going to be the rate of the slower car. So those are the two things I want to know. So I'm going to make those X and Y's. Those are my unknown. Your X's and your Y's are your unknown. So I just did that. That's how I answered this question, or how I'm going to answer this question, is by deciding what X and Y r. Okay, so I've defined the variables. That's what I'm doing here, is defining variables. Define variables. And you want to do that every time so that you make sure that you know what you're actually looking for. Okay, now, and I've kind of drawn a picture to get that idea. Now I want to draw a table. So in my table, I'm going to have, let me see how I want to write this. Okay, we're going to do it like this. And remember how I said rate times time equals distance? Okay, so that's what we're going to figure out. And I'm going to make it like it's a table. And the first one's going to be the faster car. Faster car. And the second one's going to be the slower car. Okay, so do we know the rate of either one of these cars? So do I know this and do I know this? We actually don't know them, but we did define them. We said the rate of the faster car was X. So that's what I'm going to put here, right? Rate of the faster car is X. And then the rate of the slower car was Y. Remember, we wrote it right here. These are where I'm getting that from. Okay, and because I wrote it down, now I have that in my head and I know what I'm doing. Okay, the time. So I'm going to go up here and see, did anything in my problem give me a time? Right here it says they're going to pass in 6 hours. So that's when they're going to pass each other. So yes, it did give me a time. So for both of them, the time is 6. Okay, I could write hours next to it, but I'm not going to do that every time. Okay, so now how do I find the distance? Well, it tells me right here. I do rate times time. So I'm going to do X times 6 gives me 6X, and Y times 6 gives me 6Y. Okay, so that's how I figured out my distance. Okay, now I'm going to write out my two equations. So the first equation I'm going to use is what it says right here. It says one travels 2 miles per hour faster than the other. So I'm going to use that to write my first equation. So remember, the fast car is X. So X equals the slow car plus 2 more miles per hour, right? Because it's 2 more miles per hour faster than the slow car. So these are the rates. So I already did my first equation. Okay, that's done. Now my second equation, I'm going to take from right here, and I'm going to use this distance and, sorry, I couldn't fit this all in the same thing, and this distance up here. So I know that they're 612 miles apart. So let's look at the picture. So if I take the fast car, 6X, and I add it to the slow car, 6Y, then that's going to give me the 612 miles. So I'm going to put that down here. I'm going to have 6X plus 6Y equals 612. So you see how you can see that on the picture, and that's why it helps to draw a picture, is that both of their distances before they meet are going to equal 612 miles because that's how far apart they were. Okay, now I can just solve this with systems of equations. So I'm going to do substitution. We learned all the types last week. Now we're putting it into use with word problems. So I'm going to take what X equals, and I'm going to substitute it in for that X. I'm going to have 6 times Y plus 2 plus 6Y equals 612. So now I'm going to do distributive property. And I get 12y plus 12 equals 612. Okay, and now I'm going to subtract 12. So I get 12y equals 600. And now when I divide 600, divide it by 12, I'm going to divide by 12, I get y equals 50. Okay, before I talk about what that means, I'm going to go ahead and find x. So I'm going to go back up to this main equation, first equation, and I'm going to put in y is 50. So that gives me x is 52. Okay, so here are my two answers. Remember, up here we said that x was the rate of the faster car, And y is the rate of the slower car. So since we're talking rates and we're talking cars, we're talking about miles per hour. That might not be miles per hour, but right here they've used miles per hour, and so that's what we're going to use as our rate. So our answer is the faster car is going 52 miles per hour, and the slower car is going 50 miles per hour. So I can kind of check to make sure that this was correct with one thing. Remember, it said up here that one travels 2 miles per hour faster than the other. So is that true right here? Yes, the faster one is going 2 miles per hour more than this one. Okay, so that's my answer for example 1. Okay, and you will have some like this where there are two things that are meeting. So that's how you do it. You look at a picture, set up a table. Just go back through your notes on this one and do it exactly the same way. Okay, example 2. This one is different because it's not one where they meet, but it's still a motion one. Okay, when his Sunday school class, remember, write this all down. When his Sunday school class went canoeing. Ooh, has your Sunday school class ever gone canoeing? That would be fun, right? Bill paddled 12 miles down the river. In 3 hours. Okay, so it just told me how far he went in 3 hours. Okay, after paddling back upstream, oops, I wrote the back. After paddling back, upstream for 2 hours, he had traveled 4 miles. How fast does Bill paddle in still water? And what is the rate of the current? Okay, so we have our 2 questions there. So the first thing we're going to do is define our variables. Okay, so let me write that here. Define variables. And this is very easy because it is in your questions. The parts that have question marks on them are your variables. So the first one, we're going to say X is Bill's paddling rate. So how fast does he paddle? And our second one that we don't know, okay, so I got that first one right here. How fast does Bill paddle in still water? So that's a rate, how fast something's going. So our second one is, what is the rate of the current? So our second one is going to be rate of river current. Okay, so we need to know 2 things, or in our table, we're going to talk about 2 things. His traveling upstream and his traveling downstream. So let's make our chart here. Still want y'all to be able to see the question while I'm writing the chart. So remember, on moving ones, we're doing rate times time equals distance in our chart. And I'm just going to kind of put a table here. Okay, and we're going to have the first one is going to be traveling upstream. And the next one is going to be traveling downstream. So when you're traveling, I don't know how many of y'all have gone in waters and stuff, but which one do you think is harder, traveling upstream or traveling downstream? Well, downstream means that you're going with the current, so you're going to go faster. If you're trying to paddle up the stream, it's a lot harder and you're going to go slower. Okay, this also works with, and you'll have problems where it says you're running into the wind or you are running with the wind or the wind is at your back. So that means you're going to be going faster than you would if there was no wind, right? Because you have the wind to push you. Well, this is the same thing. When he travels downstream, he's going to be going faster than if he was just in a lake where the water was still. Okay, so but they do want to know his paddling rate for when it's still. So they want to know how fast does he paddle if he were in a lake instead of a river. So we're going to figure that out. Okay, so the first thing we need to know is our rate, our time, and our distance. So let's talk about the traveling upstream. And the first thing that I see up here after paddling back upstream for 2 hours, so there's my time for upstream, okay? So that was an easy one, so I just got it out of the way, okay? And if you look up here, that down this river is in 3 hours. So I'm going to put the 3 for downstream, okay? Now we need to find the rate. So the rate is going to be Bill's paddling rate. Okay, if he's going upstream, it's going to be his rate minus the river's rate, okay? Because remember, he's going to be going slower. So let's say he's going, you don't have to write this, or don't write this. Let's say he's going 12 miles per hour and the river is going 6 miles per hour. Then he's only going to be going really 6 miles per hour. So this isn't what he's going. This is what he's paddling. So because the river is slowing him down, because it's pushing on him, right? So if he's going downstream, though, that's going to be a plus. He's going to add the river's rate because it's going to be how fast he can paddle and how fast the river is flowing. Okay, so now we can figure out the distance right here. So how do we do that? We do rate times time. So that means we're going to have 2 times x minus y. And down here, we're going to have 3 times x plus y. Okay, now we have found the distance. So we need to say, do we know the distance in these problems? And we do. On this first one, it says he went 12 miles down the river. So that means I'm going to use this one, the downstream, and I'm going to make that, because it's distance, I'm going to make that one equal 12. And if you look at the upstream problem, over here it says after paddling back upstream, so I'm looking for that key word, he traveled 4 miles. So that's my distance again. But this distance is for upstream. So I'm looking right here, upstream, and I'm going to use that one. So I'm going to do 2 times x minus y equals 4. Because remember in the problem up here, it says 4. Okay, so there's my system, and now I'm going to solve this problem. So how am I going to solve this problem? Well, for this one, I can multiply everything out and then do my system of equations. So I'm going to multiply everything out. So I get 3x plus 3y equals 12, and 2x minus 2y equals 4. And then remember, this 3 is only going here. It doesn't go across to the last part. Okay, and then now we need to find, we're going to do this by addition because I think that is the easiest one. And so I'm going to multiply everything in this one times 2 and everything in this one times 3. Why did I do that? Because I want to get rid of these. So I get 6x plus 6y equals 24, and 6x minus 6y equals 12. So when I add these, I get 12x equals 12. Now I divide by 12, and x equals 1. So remember what x was up here? X is Bill's paddling rate. So right now I know that, wait, did I do that right? I know that the x is 1. Okay, so I'm just going to double check here that I did this correctly. Okay, so now I'm going to go in and do find my y when x is 1. So I'm going to do the first equation here. And I have 3 times 1 plus y equals 12. And so I'm going to multiply everything out of here. So I get 3 plus 3y equals 12. Oops, I did that wrong. Subtract 3. And I get 3y equals 9. Divide by 3. And y equals 3. Okay. So these are my two rates. So I have Bill's paddling rate is the x, and the rate of the river current is the y. Okay, so that is what you will be doing in your assignment today. Okay, so if you're doing a motion problem where two things are meeting, follow the example of 1. And if you are doing a motion problem where you have something like the wind at your back or a flow of a river, anything like that, then you're going to use the example 2. Okay, that's it for today.